Hi, my name is Anthony Warwick, and I wrote Number Theory, the Queen of Mathematics. This report explores the idea that number theory is not limited to simple investigation of numerical arithmetic, nor abstract mathematical considerations, but also may be used to contextualize the analysis of thought and meaning in general, in addition to having direct applications to the real world. I begin by covering some well-known properties of integer arithmetic, such as equivalence relations, equivalence classes, congruence and congruence classes, in order to prove the Chinese remainder theorem for coprime moduli. This speaks to the motivation for the report. I use the Chinese remainder theorem as a core theme to demonstrate how we may piece together novel concepts, generalizing from specific cases. I make specific note of the idea of particularly distinct concepts that are exemplified by coprime integers. Following this idea, I go on to explore how philosophical concepts may be analyzed from a mathematical standpoint, using the necessity to order symbols for meaningful communication to demonstrate a possible link to a kind of mathematical philosophy. As an example, I note that simply because two objects may share similar properties, this does not mean they are necessarily the same. Noting this requirement for a form of relaxed equivalence, we may derive the notion of isomorphism in abstract algebra. This leads into a section on abstract algebra, where I note how the apparently simple tools we have developed allow us to extend to domains that are no longer restricted to the integers. I cover some well-known tools of abstract algebra, proving various theorems for groups and rings such as the first isomorphism theorem for rings, and providing some simple examples to demonstrate the connection between arithmetic on the integers and abstract algebra. Following the theme of piecing concepts together, I go on to introduce and prove various properties of ideals, being somewhat analogous to the abstract algebra version of these particularly distinct objects I touched on earlier. This flows into the proof for the Chinese remainder theorem for ideals to finish the theory portion of the report. Finally, I outline an application of number theory in modeling biochemical reaction systems. For a set of chemical elements, there is an associated set of reactions that take the form of reactants, inhibitors, and products. By equipping a symbolic representation of these reactions with a decay duration, we may express a system of reactions as a sequence of numbers. The Chinese remainder theorem then allows us to determine various properties of the system. By using formal mathematical notation, intuitionist logic, and the presentation of an application, I demonstrate that number theory truly is the queen of mathematics. Thank you very much.